Hi, it's Mr. Tomlinson here with 2002. This is 2002. There you go. 2002, number 4. Okay, so we're going to start with this. Commercial airlines need to know the operating cost per hour of flights for each plane in their fleet. So basically what they did was they ran a regression analysis of the number of passenger seats versus the cost, okay, the operating cost. And they had some values as low as 216, which is down here, and then some values as high as 410, which would be this guy right here, okay? Operating cost per hour ranged from 3,600, which is right in here, up to 7,800. So you got some computer output from the regression analysis, which is down here when you pull the problem. And then you've got the questions below. Okay, so we're going to start without looking at the data, the scatter plot, because the first question really doesn't require the scatter plot. Okay, and it's what is the equation of the least squared regression line based on the computer output? Now you've looked at a computer output. You've looked at a computer output before, so you know how to interpret this. You know that what is next to constant right here is the y-intercept. So we're going to say that we know that we are predicting our operating cost. So it's operating cost hat is equal to 1136 plus, and then next to the number of seats here is 14.673. So it's 14.673 times the number of seats. Now, if you write this as y hat and x, you must define the variables. So if you write x and y, you must define what x means the number of seats, and y means the operating cost. If you don't do that, that's going to be a problem for you with the AP. And a problem, really, if you're writing a scientific report, you want to make sure you're writing in context. Okay. Part B asks, what is the correlation coefficient for the operating cost per hour? Well, you've got r squared here, you've got r squared here, and r squared with this adjusted. We don't really use that. Hardly, you'll never use that. So we're going to use r squared. So what is the correlation coefficient? Well, we need to take a quick look one more time at the scatter plot, and we see a positive association. So we see a positive association, and because we see a positive association, then we know that r is positive. So since we have r squared here, all we need to do for B is take r is equal to the square root of 0.57, and we know that this value is positive. If this had a negative association, we would change that to negative, but we don't, so it's 0.755, and that is the correlation coefficient. Okay, so for part C, suppose you want to describe the relationship between the operating cost per hour and number of passenger seats only in the range of 250 to 350 seats, okay? And it kind of feels weird to say the range of 250 to 350 because it's really the domain, but we're thinking about the values, okay? What does the line show? Does the line shown in the scatter plot provide the best description of the relationship for data in this range? Okay, I brought the scatter plot up again to the top here so we could have a look. If you look at these values from here, 250 to 350, which is what our range is supposed to be, then I'm going to just draw this on here in yellow, what my sort of box of what I want to examine. What do you notice about the slope of this line? Does the line shown in the scatter plot, which is this, best represent what we have here? Okay, the answer is no, it does not. And the answer is no, okay? And answer the question, see if you can come up with the answer to the question, and I'll put my solution up. This is my answer. No, the general relationship between seats and operating costs between 250 and 350 seats is negative. So the correlation is negative, which would mean we need a new regression line just for this data. Okay, so if we're just looking at this data, the regression line, it's clear to see that we would have this sort of relationship here, something like that, something negative. okay? And that's why this particular set of data is separate than the original regression line. And if you look at the scoring guidelines, you can see how it's scored, but certainly that's up to you if you'd like to do that.